Welcome you all, dear students. I see a few of you. I hope some more will join in quick time. We are here today for the first of the various subject presentations that you yourself students and myself and possibly other invitees that I can find to tackle any topics that are of interest. Of course, the progress of our this lecture series depends on the enthusiasm and the response that you guys show. So let us see how it goes forward. But as far as the two students who have accepted, Sahithya and
Moksha.
Moksha, yeah.
Mm.
So I guess we will get started with those two. I'm very happy that they came forward that day and have held on to the promise, and seems to be a smashing presentation there. So I welcome Sahithya to start
Yes,
her presentation. Thank you.
sure, sir. So I see only 7 participants. Should we wait?
Okay, we will wait for a couple of more minutes. Welcome, Sahithya, to proceed.
Sure, sir. So first of all, greetings to everyone here. Especially to you, sir. Good evening, sir. And thank you so much for giving me this opportunity to present on this topic, queuing and data buffering. It was a very informative session for myself to learn about this. Queuing was something that we studied since first semester, but data buffering was something new for me too. So here goes. I hope this presentation is very informative for you guys too. So yeah.
It is already smashing with the proper animation there. So well done.
Thank you, sir. Yeah. I've tried to make it aesthetically pleasing. So let's see how it goes. So agenda for the day is obviously to understand the concepts first as to what is queuing and what is data buffering. And then coming to the main topic where we are going to learn about the interconnection or how data buffering and queuing is interrelated. And then we have a case study and finally a conclusion. So yeah, as an introduction, so let's imagine it's a very busy day at Starbucks or a very busy day at any coffee shop for that matter. There is a very long line of customers. So all of you have been in queues and obviously the first person in the line gets the first coffee, right? So this is exactly how queues work. It works in a very similar manner, and the principle to be known is the first in and the first out principle. That's simply as simple as that. Queues works is that. Now to understand what is data buffering in as an analogy, let's say now there's a barista or like the coffee maker. So he doesn't make all the coffees at once. He starts by making the next coffee a little bit earlier than the current coffee. Like this, as soon as we hand over the current coffee, they immediately finish the next one. So there is no waiting period in between. So this is exactly the concept of buffering. So then if I have to explain it in very technical terms, buffering is when data is temporarily stored while it's being processed. Yeah. So again, queuing and data buffering together, they can be used to optimize the flow of data or so processing is not intercepted. So let's explore how these two concepts are helping us, and let's explore these two concepts individually, and in the end, we should come to a case study. Now, understanding queuing. So what are queues, right? Queues are linear data structures. So we have learned DSA, we have learned data structures like stacks, queues, trees. Now, particularly concentrating on queues in this matter. So a queue is a linear data structure that follows a first in and a first out principle that we call as a FIFO principle. So where elements are added at one end and removed from the other end. So as you can see here, we have a rear end here and a front or the head region here. So to come to some basic operations in a queue, the most basic ones, we have an N queue, that means to insert an element into your queue. And then there is a D queue, that is to delete an element out of your queue. The isEmpty function is to check if your queue is empty or not. And this isFull function to check if your queue is full or not. And also there's something called as a peek function, that is so that it returns the first value, the element that is there in the front position of your queue, without necessarily having to get it out or to extract it out of the queue, so that you know what is there in the first. So that is all about queues, a basic understanding exactly as to what is a queue, like how we discussed in our analogy. Is when it's a normal queue, like where you know, in a coffee shop maybe, or maybe in a college canteen, or even college mess. A basic queue is wherein a queue system is followed, where the first person gets the first food. That's how it is. Now, coming to the types of queues. So primarily we have 4 types of queues. That's a simple queue, like how I explained earlier. The first element inserted in the rear region and the first element to be removed is from the front region. And the functions include the N queue and the D queue. Next, coming to the double-ended queue. Now, this is where the insertion and the deletion operations are performed at both the ends. So since it's also called as a DQ. So a DQ supports both stacks and queue operations. So it can be used as both. So that is an advantage. Okay, so problems where data has to be removed or added from both ends can be solved by using DQs. Now, coming to circular queues, so these are a very beneficial, let's say, like a hybrid queue, wherein the rare region is like that is a last element. It points to the first element. That means the last element and the first elements are connected together, which forms a circle or a circular queue, and it's also called as ring buffers. So one of the most advantages of these circular queues is that the unused memory locations that is used especially in their standard queues, it is very useful in your circular queues. So actually what happens is in standard queues we say that once an element is removed from the front, these spaces are not like reused. Okay, like to understand circular queues, let's take an example of a conveyor belt. So once an item is removed from that space in a conveyor belt, then it is not left unused. A new item is added at the other end. So this is the main advantage of circular queues, where no space is left unused. Okay, and coming to the next one is the priority queue, and wherein each element that is associated in the queue, it has a certain priority. So then the element with the highest priority is the one which is DQ'd first. That's how it is. I have given pictorial representation of how each of these queues work, so it helps you. And next thing to okay, so then we have, let's say, printer queues and message queues. I'll come to this later because I have a case study on them. And next example, coming to the CPU sharing memory management, that is applications where the data elements need to be processed in a circular fashion. So first of all, what is CPU scheduling? It's an operating system concept where it's a mechanism which determines which tasks or processes must gain access to the CPU's processings. So where one of the CPU scheduling techniques, like there are many scheduling techniques as such, where one of them is the circular queues, which obviously follows the first in, first out principle. So that is CPU scheduling. Next, we have the operating system task scheduling. There's applications where certain tasks or data elements need to be processed with higher priority. Higher priority, that is because, like the operating system task scheduling. Task scheduling in this case, that means it manages the execution of the tasks or the processes. So it determines which task should be executed first by the CPU. So obviously certain tasks will have higher priority and certain tasks might have a lower priority. So that's how queues are used in task scheduling as well. Now, coming to searching algorithms like our binary search, travel, obviously use queues. Like we've never noticed them by solving problems in searching algorithms. But honestly, if you look close, you see that they all use queues to keep track of the next they have to visit so that they can compare with the previous element or so. And similarly, something similar to searching algorithms is a job scheduling. This is also an operating system concept with like scheduling concepts, which means that it's a way the computer decides in order to decide which work to be performed by the CPU so that the most efficient processing takes. Processes uses the queues in order to determine which maybe like instruction to undergo next. That's how that we can say is the uses of queues. Yeah. So now coming to the implementation of queues. That let's consider this case where there are like multiple employees in a company. They're all busy at work and they send multiple print jobs to a single printer. Now, as you all know, a printer can only handle one job at a time. So the jobs are lined up in a way that they are received. So what when a job is lined up to be executed? That's nothing but an application of queues, right? It lineups all the jobs that has to be printed, like all the print jobs it has to be, it was received. Now, this is just an analogy, but again, coming to what happens in, let's say, like a multi-thread environment. So before I come to multi-thread environments, for me to explain what a thread is, let's consider one more analogy where so there is a worker. Okay, let's consider there is a worker in a factory and work to do. Now he can work on it along with other workers, sharing tools with other workers. Your tools can be the resources in your system. Okay. So is that a thread is a part of a program that can work independently from the other parts. Okay, making the whole program super efficient. Okay, so that is a thread, I can say. Like a thread is a collection of certain programs that can be, that can be processed independently. So, yeah. So again, when I was talking about like a multiple thread environment, so when these threads need to like access like a certain shared resource. So example, a printer, let's say. So these processor threads are they lined up in a queue, or these programs are all lined up in a queue so that the resources can handle them one at a time. So again, this is one of the major uses of queues in a multi-thread environment. Or something else like queues can also be used in a network traffic management. So where when data is sent through a network, it's sent through packets, obviously. And so then these packets are queued at the sender's end and they're dequeued at the receiver's end, right, through a network. So by doing this, we can also minimize the data loss over the network. So these are few of the very much applications of queues in programming. So
Yeah.
yeah,
Just before
how I
you
can.
move on, one
Yes.
important point I want to highlight. Well done. The points you explained the things very well.
Okay,
The
sir.
important point here about the printer being shared is one is that uh, is an expensive resource, especially good
Yeah,
high-end printers. So a central resource. And why it should be shared? Because it's unlikely a user will be printing all day. So it's a good
exactly.
resource to be shared across the time that is available with
Exactly.
many people being served. And the third important thing here with respect to queuing here is each person who is launched a job for a print doesn't have to hang around for his printout to come out.
Yeah,
His
exactly.
computer is freed from awaiting that process and he continues
Exactly.
his work, and later
Yeah.
he checks the queue like Sahithya ji said. There is a queue monitoring system where he checks and okay, he'll go fetches the printout. So this is
Yeah.
very effective
Also,
implementation of
also
the
the
queue.
employee can continue with his work without, having to worry about the printer printing his
Ab-
work. So that's
Absolutely.
already been taken care of. So that's
Absolutely. If
again
there
the
is a failure, he will get a message, notice. All those
yeah,
are built into the system.
exactly. So it's very efficient for the
Yeah.
employee as
You
well.
mentioned about the data loss. In a computer environment, data loss is almost reduced to null nowadays. It historically
Yes,
due to
actually, that was in a case where data buffering is not used. So I'll
yeah.
come to that later on.
Uh-huh. Yeah, data loss
Yeah.
can happen. For example, in a network, data loss packet losses can happen, but they
Yeah.
build higher level system by which the loss is not transparent to you. The loss is
Mm-hmm.
acknowledged by the hardware and the resend happens so that data is patched up. Okay, that is the
Exactly. Yes.
reality.
Okay, sure. Yeah. So here we come to the uh, end of what understanding cues. So I hope you can take some time to recollect on what we've understood from cues. So before we can move on to data buffering. Yeah. If anyone has any doubts in queuing, feel free to ask me.
No question is a bad question, guys. In a in a presentation, the opportunity is there to expand the knowledge base of each one of us by questioning things. And if Sahitya herself can't help, I will see if I can help. If we can't, we will note down the question and research to come back with an answer to you in the WhatsApp group.
Sure. Okay, so I think we can move on to data buffering then. Okay, now to understand what exactly is data buffering, it's always better to start with an analogy as to understand in our day-to-day lives how we are unknowingly using buffers, honestly. So again, imagine that you are at a restaurant. So in a restaurant, obviously, kitchen is where the food is prepared and the dining area is where you consume it, right? So suppose the kitchen keeps sending out meals as soon as it finishes, like it's prepared them. Then the server, then what would happen? Like it would be such a ruckus, such a mess, right? So then obviously the servers would not be able to keep up with you, and you too, you and me as well would have received like 2 to 3 meals all together, and we wouldn't even be being able to finish the current one, right? It'd all be a mess. So what do we do as human beings in a restaurant? See, the kitchen simply here acts as a buffer. How? It's like once a food is prepared or the meal is prepared, it is kept in the kitchen or in a hot plate for a while. Okay, before the servers they can come and deliver the meals to you in pairs, and also they deliver it only when required. So until then, the meal remains in the kitchen or in a hot plate. That's how it is. That's exactly what we are talking about here. That is data buffering. So here, when, like it said, the data is being transferred from one place to another. Okay, and especially, let's say, when the speed of a certain device, for example, a printer, which is super slow as compared to the speed of a CPU. Okay, when they're not able to match, that's when a buffer register, let's say, is being used in between them, so that the speeds of both these resources can be synced and no waiting period, be it, or any other interruptions occur during this data transfer. So that's all that is you have to understand about data buffering. That's it, actually, honestly.
That is a perfect description of buffering, where the faster parties and slower parties each
Yeah,
work at their pace, which is required for them. And the faster party doesn't hang around. He leaves
exactly.
it
So,
at the buffer and moves. Like your example was superb.
yeah.
Actually, for example, if you go to places like McDonald's, etc., if you notice, they will actually have exactly what Sahithya described, where a hot light portion area where they leave the burgers with the
Yeah.
vegetarian queue, with the other queues, etc., and they are picked up in order by the party who is distributing them.
So,
Very
yeah,
well
and
described.
yeah. Okay, so that's it about data buffering. So let's come to the importance. So the role in managing data flow between processes or systems that operate at different speeds. Like how I said, a printer speed and the CPU speed are very different. Right. So again, one of the most important points to note here is the matching the data rates. So what this essentially means is that the fast producer system, let's say, it continues producing data without having to wait for a slower consumer system. So the CPU doesn't have to wait for the printer to accept data and print it so that it has to process the next data. Right, so that's what I trying to convey to you about matching data rates. Also, the next one is a smooth data flow. That is, it acts like stabilizers, basically, essentially, to sync the varying speeds of the data processing. Next, like how I mentioned earlier, is preventing data loss. So now if a producer produces data at a high speed than what a consumer can even handle or take in, so then there are chances to lose this excess data. So this is uh, greatly prevented by using buffers in the system. Okay. So this is the entire importance of data buffering in computing nowadays. Yeah. Now this is like a great application to understand data buffering. At least for me, it was. Like okay, let's say you watch videos on YouTube, on Netflix, and everywhere, and then at times it's really annoying when this buffering or loading sign comes in. Right? Have you ever given it a thought as to what exactly this loading sign is? So that's how I could link data buffering and this common phenomenon that happens to me almost every day. So yeah. Okay, so let's say you watch videos from Netflix and the video doesn't
Oh,
play.
by the way, Sahithya only watches educational videos.
I hope I could say that too. Sure, sir. Yeah. Okay, fine. I can continue. So, yeah, so the same thing. So now when you're streaming a video or let's say a movie or an educational video itself, so the video doesn't play from server directly. So instead, what's actually happening here, or at least what Netflix is doing here, is that instead of playing it directly from the server, a portion of the video is being downloaded into your system and it is being stored in a buffer on your device, right? So then the video plays from the buffer. So even if your internet connection is slow or your video is always playing, it's still playing. Now, so then the next half of this video, this part of this video is being downloaded in the backend. But sometimes what happens is the buffer is emptied way before this is being reloaded. The next portion of the video that is being reloaded, the buffer is already empty before that. So then what happens is then our video gets paused and then there's a sign that says loading or reloading or buffering. It all means the same thing, that your device buffer is being reloaded or filled at that moment. So that's like a beautiful example of data buffering that we can relate to at least. Yeah. Okay.
Absolutely correct
So
example. Good, thanks.
yeah. Okay. Fine. So now that we have understood the topics individually as to what data buffering is, as well as what is queuing, now let's take a second back to give us a thought, as to how these two concepts can be interrelated. So if you want me to repeat it for you, what is data buffering? It's like a temporary storage unit to store your data before it's being let out. Okay, and what is a queue? A queue is like a linear data structure that it follows a first in, first out principles. So if you can recollect and give it a thought as to how, like, twitch your brain a little bit. Like, let's say, how can these two be interrelated or interconnected? There has to be a reason why Sir has given me these two topics together, right? Not to just explain them differently, but there has to be a reason. If any of you could make an attempt to think about it, think for a second.
Yeah,
None of you?
please come forward and give your opinion, saying that you agree or you think this way, something. Think of a line and come back with to encourage her, please. Okay, Moksha, can you unmute yourself? What exactly have you understood by Sahithya's description about the relationship between queue and buffering?
Hello. Am I audible, sir?
Yes, you are audible.
Yes, sir. Hello.
Hello?
You are very
Yeah.
much
Sahitya?
audible, Moksha. Go ahead.
Okay. Yeah, Sahitya, could you repeat what you just said? I couldn't hear you.
Yeah,
Okay, yeah. See, I explained what queues are and what data buffering
Yeah.
is, right?
Yeah, we should we're done with it.
Exactly. So, like, just give it a thought as to how we can interrelate or connect these two concepts together, how these can work hand in hand for, better optimized use of some process, maybe. If you could give it a thought, otherwise we could continue.
Like since it's queuing and data buffering, part of the video can queue as it starts to buffer, right?
Yeah.
Yeah, that's
I mean, it's,
but no.
see, I'll tell you, it's
Okay, fine,
simply
fine.
like, see, a queue can be simply used as a data buffer, right? That's it. It's like queue is being used as a buffer. Well, because what was a queue? A queue was like a linear data structure, or like it was like a data structure that follows the first in, first out principle. It stores certain values for a certain time before it is let out. And that's exactly what data buffering is. So here in this case, we're using a queue as a buffer. So yeah, so again, so ingestion, that is
okay,
data enter.
let me just intervene to clarify the subtle difference,
Yes, sir.
Sahithya. Okay,
Yeah.
so let us say we are. I will again use a real world example, which is easier for all of us to observe. Let
Okay.
us say we go to a railway station to book a ticket,
Yeah.
and all of us have to stand in the queue, and only one person from the time he goes steps in saying which station, how much money, which class, until he finishes another guy can't enter. So there is actually no zero buffering there. So like you are stuck there until all the people ahead of your queue are done. You can't
Exactly.
walk away.
Exactly.
And suppose there were multiple service servers, it helps that you can choose the shallower queue, because there is
Yeah.
no buffer anywhere. Almost you, like Sahithya said, you yourself are the buffer, because you're sitting with your request in your head going through the queue. You can't hand it over to some party. Now
Exactly.
instead, if suppose there was a method whereby there were
Mhm.
some agents sitting around collecting your request in a sheet, you quickly handed over the whole request to them, the exact amount required for that and his agency fee. Then he's
Yeah.
collecting all the sheets, and then he puts his time and effort to one by one get it processed at the queue head. Okay, so he is
Mhm. Yeah.
acting like a buffer there. where you walk away and you can come back after a coffee or something and collect your tickets from him and go. Okay, so
Yeah.
that is a buffer offers that service to you where it takes your request in, lets you move on, like a CPU moves on to its next job, and the buffer will, when the time comes, give the data to the
Okay.
printer. And in printer finally has to acknowledge printing done. So that is the ticket returned back to the original CPU saying here is your ticket, completion ticket, like that. Okay,
Okay.
that is the
Yeah.
difference. Buffering helps that walk away process. If you didn't
Hmm.
have buffer, the CPU will sit there waiting for the printer to be free, then start transmitting data to it. That's a disaster.
Yeah. Exactly. Oh, okay. Yeah, so that's
Because
all
even then
about
there
it.
is a queue. Even there are 20 or 100 computers where we're talking to the same printer, but they are talking one at a time and stuck with them, right?
Exactly. So
So
yeah.
then they themselves have to internally implement their own buffer and concurrent threads, etc., to make it transparent to the user. But if there was a printer server doing the job, which is the agent in the railway station,
Hmm.
then the job is simplified
That
for
acts
the
like
computer.
a buffer. Okay. Yes, sir. So yeah, that's like exactly how sir explained. Mm, so that's how a data buffering and queuing can be interrelated. So yeah. So moving on to the case study. Okay, so let's say the case studies on how the queuing and your buffers are related. So yeah, so imagine yourself in a concert where a band is playing, okay? And you're recording it on your phone so that later on you can share. Now the band is playing continuously, but your phone it can save certain amount of music at a time, right? So this is where buffering comes in. So in network communication, that is like particularly in routers, um, so let's say in the concert itself, in our analogy, the concert is behaving like the internet, the band's music is the data, and the phone is your router. Okay. So when the incoming data or that the let's say the traffic in this case, the incoming data, it exceeds the overall output capacity, then this results in the router experiencing a congestion. Okay. So then this can be solved by the router, implementing some buffering technique, let's say. So the one of them is the first in first out principle, like exactly how we explained earlier. The same queuing scheme is followed by most routers, like it's the most common one. And then what it means essentially is that all the packets are extracted from the queue in the same order as they arrive. That is nothing but the first in first out principle. So next, coming to the priority queuing. So this is where the router bifurcates the data into multiple queues. It's based on some kind of a priority. So considering our analogy, it's like each queue is handled, let's say like you have multiple phones that is recording different parts of the concert. Like one is recording the drumming, then the singing, and the guitarist, and something like that. And you keep switching between different parts, between different phones. Now this is called as a priority queuing. Okay, so each queue it's handled again in the first in first out manner, and this is considered to be more efficient. So that's exactly how again queuing and buffering is used together in this case study, for example. And yeah, network communication is one of the I can say like places where it is used most. Yeah. So that's the end of the case study. Now coming to the conclusion, like how we saw, is like a summary of all that we've seen today. There's a queuing and buffering, that the first thing and the first out nature of queuers, and the queuing discipline is like first and first on a priority queuing, like as explained in the case study. And then again, overflow handling, this strategies that include dropping new data over includes increasing the buffer size. So this happens when the data you are including in queue is like way above its capacity. So that's when there is a possibility of your data being lost. So yeah, so that is coming to the conclusion as to what and all we've gone through today. So pretty much. So yeah, thank you so much. I'm very open to feedbacks and also questions for sure.
Excellent,
So
Sahithya. I think for
yes.
a first presentation on buffering and queuing, Sahithya's covered the base overall understanding with very good real world examples. Highly appreciated. I thoroughly enjoyed, and I'm not saying just because, just to falsely encourage, it's truly well done. I mean, I had asked her if she wants some intermediate review help, etc., but she has been able to single-handedly handle it without any assist, which is a very good. See, in this lecture series, what is more important is one is you lose the stage fear for yourself. Okay, so
Yes.
Sahithya has overcome that completely. I mean, she may have been already ready for it, but at least I know she is now passed with full colors with respect to not having any stage fears, allowing for interaction, listening to what somebody else says and understanding and adjusting to that. All these things she demonstrated. Sometimes I in between jump in just to just to create that situation for Sahithya so that she is dealing with it correctly. Okay, so
Okay.
apart from the subject what she presented today studied, it is the style and substance of how she handled herself we have to appreciate and pick up cues from that. Okay, so as far as the subject itself, she has dealt with it very well with very good real world examples, and rightly so, because it's at a very preliminary level, and she is also in the early years of her engineering. She has not tried to take us into the mathematical end of it, but believe me, you others, there is a lot of deep mathematics of probabilities and distributions and things like that involved in this with equations. There is a theorem, several theorems and several methodologies proposed by various guys. One guy is called Kendall. So this Kendall theorem or Kendall law or something it is called is very important in queuing theory. Why I'm bringing all those is because when you guys enter into the real world, whether you work in the software area or whether you work in the VLSI hardware area, queues you will deal with. Okay, always. And when you do your system design, how much buffering I will allocate becomes a big problem, and then you can't just second guess and put something and go try it out in the real world. That we do also, but initially we go through the theories and computations to proposed sizes and try to slightly oversize and design the buffers. So those theories at the right time will be also good mathematically to understand. But that's a little deep now. That's okay. Understand that it is not all just kludge. There is a mathematical approach to buffering. Okay. So
Yes.
with that, I will hand over to others who may have question. I think Professor Dr. Rajendra sir is also here. I would invite him also to Patil sir, if you can also provide some feedback before other students can ask questions.
Hello, good evening, sir.
Good
Hello.
evening.
Namaste, sir. Namaste. You are audible, sir.
Yes, sir. Thank you. Sorry for joining late because of, in my mobile, I don't had this Zoom app. Just I downloaded and just listen to
No
Sahithya's
problem, sir. There is a
presentation.
recording. We will share
Yeah,
it
yeah.
later for
Okay.
those who missed it for various
Yes,
reasons.
sir.
But
So,
thanks for joining to encourage your student. I was just
yeah,
praying that
sure, sir.
you, sir, will join, and I'm thankful.
Yeah, yeah. And just 6 to 7 minutes I heard her presentation. It was very good. She told all about the concept of buffers used. Yeah, it's a very good Sahitya. Congrats.
Thank
The
you, sir.
presentation flow is very, very nice. Okay, the last points, what I catched up is, yeah, it's perfectly correct. The terminology like FIFO and other things also very important because,
Yes.
even in designing the microcontrollers, memories, buffers, so we use this first in, first out, first in, last out, some kind of a stack concepts. So all these are very important. Since just now you passed out third semester, I think in
Yes.
coming semesters you are going to come so many things, and at the end of the eighth semester you'll be able to design so many system designs. Okay.
Yes.
Anyway, congrats. Thank you.
Yeah.
Thank you.
Thank you, sir.
Yeah.
The students, do you guys have any question, please? Or you can also, offer your comments. Good and bad, both are fine, guys.
Yeah.
Open. No, I think students need to pick up a little more courage to unmute and propose things. I will
Yes.
not force anybody by calling them by name. I think I put Moksha in a tough wicket a little earlier, asking her to pass observations. Okay, Moksha, you unmuted. You have something to say?
Sure. No, I have no questions as of now, but I just like you really did a good job. I just wanted to congratulate us. That's why I
Oh,
just
thank you so much.
Excellent.
Yeah.
All right, guys. So,
Okay.
Sahithya, for having successfully delivered this, will get a special gift from me. I will interact with her to have the gift sent, which will be a utility gift, not some Netflix membership. Don't worry
Oh,
about
sure.
that.
Okay. That's fantastic, sir.
So, thank you very much, everyone. And
Thank
we
you
will
so
meet
much, sir.
again. I think Moksha is going in. Moksha, you're getting ready for second.
Yes, sir. I'm getting ready. I'll be speaking on grade codes on the first of
Super, super. We look forward to it. Meanwhile, I was just waiting to see how the response will be for. I think a few more students could have joined, but I appreciate Vaibhavi, the other Sahithya who is there in the class,
No,
and
sir. I
Maul.
just joined into True Accounts.
Okay, good for adding to our numbers.
Yeah.
Maulya, Sinchana, and Lakshmi ji, all of you, thanks for joining along with Moksha. So have a nice evening. Goodbye. See you all on second evening at 6:30 with Moksha presenting to us. Please
Sure.
talk to your other friends and bring them in. Okay. You will have other WhatsApp groups. Just hammer them to join. Okay. All
Okay,
right.
sure.
Thank you.
Thank you, sir.
See you. Bye.
two.